My name's Steve Russell. I'm a software engineer here at Swinton Technology. I work as part of a team developing TruST, which is our Metering Supervisory Computer solution. It first shipped in 2011 with many man years of experience before that in developing solutions. Each engineer has worked on site alongside our customers and operators, so we're very familiar with the environment and tasks you need to solve. I'm going to go into some detail of TruST now. At the centre of TruST is our shared memory database. It's where we store and exchange all our live data, from communications devices to reporting and UI and other applications that consume that data. It's stored in memory in a structured way, and the structured objects, as you can see on the screen here, such as integers, reals and strings, are different data types. In addition, we import the flow computer configuration and generate structured data points for each data item in the flow computer. We use Postgres SQL database to store data historically, such as for reports, or create more interesting relationships for like batch data. Batch data might comprise of several loads. We even utilize the statistical analysis maths functions within Postgres to perform our CBM analysis. Reporting is achieved by using Excel as a templating mechanism. So you've got the full power and formatting of Excel and its charts as a template, and then TruST's reporting engine will populate that template, produce a PDF displayed in the user interface. You don't need Excel to be installed on the server. Our alarm management includes grouping, prioritising and suppressing of alarms. TruST totals are not simply summations of totals you find at the flow computer. They are derived from differences in flow computer totals to generate a TruST increment, and that is applied to all the TruST period totals. It gives you several key benefits. TruST security includes encrypting all the configuration and the files that hold the totals, which are used over power reboots. They're all encrypted. Metering calculations have checksums. So if we change the core metering calculations, the checksum will change and you'll be notified. During setup, security policies are applied to Windows to harden it, and user credentials are stored encrypted. Also during setup, we use this rapid development tool to import flow computer configuration. Within seconds, we have communications maps to allow the flow computer to talk to TruST, mechanisms for retrieving events, alarms and reports, and we've also recreated the structured real-time shared memory database for the objects found in the flow computer. We have a duty standby flow computer support. We're flow computer independent. TruST is a bit of a metering tart when it comes to that. It will talk to anything. And we support many different comms drivers, which we write ourselves. Metering station functionality. Well, TruST is very scalable from a single board, a Windows 10 solid state computer, to a duty standby 2019 server architecture. There's no tag licensing scheme. So if in a few years' time you come to extend your site, you won't be hit with an additional cost if you increase in the number of tags on site. Other TruST applications include, top left, you've got the user interface, of course. It's where the operator interacts with the plant. It can click on valves and change process data. It's a tabbed interface. There's a collapsed navigation bar to the left, and you've got alarms banner at the bottom. For our engineers, there's also an editor, which is a drag and drop interface to allow us to create these mimics. We have trending, a robust solution for trending, compresses the data. Bottom left, you've got a calculation engine, which is included in most systems. Our engineers use this to add extra functionality to the system. It's a configuration exercise. They can connect up predefined logic blocks, which could be metering calculations, or simple Boolean operations, or even more complex operations are achieved using the Lua scripting language. TruST can perform routine backups. So should your RAID disk or your server fail, TruST has got the possibility to have backed itself up to elsewhere on your network. Our conditional based monitoring solutions tend to create a model representing the healthy system, and they notify the operator when the system deviates from this healthy model. It's intended to minimise routine maintenance and just allow the site to perform maintenance when maintenance is required on a particular device. Our GC solution, we have a turbine meter solution, USM, and prognosis is our orifice CBM solution. Live uncertainty was a natural progression on following our approach to modular metering calculations performed in the calculation engine. As you can see here, we've got modular blocks for each process variable. This allows us to perform uncertainty calculations in real time. We decide on the priority on which process variables are processed. We can also perform uncertainty at a batch end as well, or a period end. Here's a page of data taken from a recent project of uncertainty. To wrap up then, TruST's being built from the ground up by engineers who are very familiar with the industry. It's not some generic SCADA system that's been configured to behave like a metering system. It's done from, we've got the source code, we've got full power to add new drivers and new functionality. And as the last point states, it's still an ongoing development. We're adding new features, we go through release cycles, it's always improving the product. I hope you found this an interesting overview to TruST and hope to see you around. Stay safe.